Hello everyone, welcome to this video. In this video, we are going to learn about quantile regression using OpenMathAI. So, let's get started. What is quantile regression? Quantile regression is a supervised machine learning algorithm used to predict a continuous numerical value, just like linear regression. However, unlike linear regression, which predicts the average, mean, value of the target variable, quantile regression predicts a specific quantile, or percentile, of the target variable, such as the 25th percentile, median, 50th percentile, 90th percentile. This makes it particularly useful when the data contains outliers, has a skewed distribution, or when we want to understand how different parts of the target distribution behave. Quantile regression minimizes a pinball loss, also called a check loss, to estimate a chosen quantile. The quantile is controlled by a parameter called tau, where tau equals 0.5 predicts the median, tau equals 0.25 predicts the 25th percentile, and tau equals 0.9 predicts the 90th percentile. By changing the value of tau, the model can predict different parts of the target distribution while remaining less sensitive to outliers. Imagine you want to predict the price of a house based on features such as house size, total rooms, garage area, paint quality, finish quality, wall color code, owner phone last digit, house price. Most houses are priced between $127 and $600, but a few luxury houses are worth less than $283 in somewhere. These luxury houses act as outliers and can significantly affect linear regression. Instead of predicting only the average house price, quantile regression can predict the median house price, tau equals 0.5. The lower price houses, tau equals 0.25. Or the premium houses, tau equals 0.9. Providing more realistic predictions for different segments of the housing market. We will use this dataset for the quantile regression model. So let's get started. Open OpenMathAI. In this demonstration, we use the house price prediction using quantile regression model. Click Create New Project. Enter the project name as House Price. Choose a folder location to save the project, then click Save. To import your dataset, either click Load Example Dataset or browse for Dataset to import your own CSV file. Once the dataset is loaded, verify that it contains all columns before proceeding to model training. Scroll down to view the first 10 rows of sample data. Click Continue to Configuration to proceed. Configure the dataset by specifying the input features and output target. There's also a feature called Ignore, which can be used for columns that should not participate in model training. Select the input and output columns manually, or use Smart Suggest for automatic recommendations. There's one more feature, Signal Diagnostics. There's 3 columns. First one is column. It's tell which features are on the dataset like inputs and outputs name. Second one is VI if it tells how much correlation of the features. Third column is status if it's okay, moderate, high, redundant, and constant. Review the selected configuration. Click Proceed to Model Design. Choose a model from the available machine learning models. OpenMathAI recommends suitable models and features based on the dataset. For this demonstration, select the A quantile regression model. View the model overview, pros, cons, and real-world applications. Click Proceed to Training. You will see the selected model. Click Start Train Models. Review the training configuration. Test data split, which determines a percentage of data reserved for testing and validation. Review the model parameters and pre-processing settings. And also another feature is added that is trained from scratch or continue from use model. If you train this model before you use that option. Modify the configuration if required. Click Start Training to begin the training process. After training is complete, review the following performance metrics. R-squared measures how well the model explains a variation in the output data. Range 0 to 1. MSE, mean squared error, measures the average squared difference between actual and predicted values. RMSE, root mean squared error, the square root of MSE. RMSE is expressed in the same units as the output variable, making it easier to interpret. Engine time. The time required for the generated model engine to execute and produce predictions. Lower engine time indicates faster model execution, which is important for embedded systems and real-time applications. Fit quality. An overall assessment of how well the model fits the dataset. It is generally derived from metrics such as R-squared, RMSE, and residual errors. Model accuracy. For regression models, accuracy is commonly estimated using the R-squared value. Example, R-squared equals 0.95 accuracy, almost equal to 95%. Click Fit to Window, you will see three types. Fit to Window, comfortable, compact. Then the clear history if you click that it will clear the history before its trained model. Another is deselect and select all trained model for export. Click View Curves. You will see the diagram of R-squared residuals and residuals diagram. Click Math and Code Preview. View the generated mathematical equation and source code. OpenMathAI provides expression of the data, detailed explanation of the expression, and an implementation code. Return to the result page and click Deploy Status. Click Export Model. Choose the required export format. ANSYS, FMU 2.0, FMU 3.0, Verilog RTL, VHDL RTL, Python Bundle, ONNX Hub. You can choose any of these formats and export. You can also download the free trial versions of OpenMathAI and Twin Simulate. Thank you. Stay tuned for more OpenMathAI demonstration.